In this video I'm going to teach you, or I'm going to show you the formula for solving general quadratic equations of the form ax squared plus bx plus c equals 0, where a is not equal to 0. And the method for using this relies on something called completing the square. So let's have this quadratic equation here. X squared plus 6x minus 16 equals 0. So let's start off by moving the minus 16 to the right hand side. I get x squared plus 6x equals 16. Now if I draw this as a shape, this is basically a square of side x plus a rectangle of one side 6 and the other side x. So let's draw this like this. Just roughly, here's my square. One side is x, the other side is x, so the area is x squared. And the rectangle added on the end is, one is width 6 and the other is height x. So in total I have 6x in here. So this shape is the same as this expression on the left hand side of this equation here. Now what I want to do is I want to aim to have something on the left hand side which is x plus a to the power 2. Now the trick is, if I slice this bit in half, I end up with two rectangles, each of width 3. So if I chop off this bit here, rub it out, and we've chopped it in half, so we've got one bit that's worth 3x here. Then I take my other bit, which was worth 3x, and I add it to the top bit here. So we've still got the same amount. We've got 3x plus 3x, which makes 6x. But we've now, we're trying to make up a square of side x plus 3. That's the whole of this side plus this little chunk here. And because they have the same lengths, this is almost a square. But it's missing a bit here. The question is, how big is that bit that's missing? Well, if this bit down here was worth 3 and this bit up here is worth 3, then this is 3 times 3, or 3 squared, which is 9. So we're missing 9. So what we have to do is we have to add on 9 to each side of this equation in order to complete the square. So in brackets I'll write add 3 squared to both sides. That will give me x squared plus 6x plus 9, which is 3 squared, equals 9 plus 16. I've done the same to both sides, so that's completely okay. But now I can factorize this thing into a product of two brackets, or a square. This is the same as x plus 3 all squared, because I've shown this from down here. This was x plus 6. This is x squared plus 6x plus a little bit, which is the same as x plus 3 times x plus 3. And on the right hand side I have 9 plus 16, which is 25. And now we know how to solve this thing. We just take the square root of both sides, and I'm left with x plus 3 equals plus or minus the square root of 25. We know the square root of 25 is 5, so this is plus minus 5. and I'm left with just x plus 3 on the left hand side. So I have two solutions. X can be either, I have to move the plus 3 over to the other side, I get x can be negative 3, plus 5, or minus 5. So my two solutions are x1 equals minus 3 minus 5, which is minus 8, or x2 equals minus 3 plus 5, which is plus 2. So that's an example of how you complete the square. Now we're going to have to complete the square using the more general form of the equation. Let's create a new slide. So again, generally the general form of a quadratic equation is ax squared plus bx plus c equals 0. Now, in the form that's most commonly used in the Swedish syllabus, we go from here and we divide all terms by a, and I'm left with x squared plus b divided by a x plus c divided by a equals 0. And this thing is normally written in the form x squared plus px plus q equals 0. So when you have an equation in this form with no coefficients in front of the x squared, a coefficient in front of the x, and a constant term q, you can apply the so-called PQ formula. And I'm going to show you how we arrive at the PQ formula. So what we have to do is we have to, like we did with completing the square, we have to subtract the constant term from both sides. We're left up with x squared plus px equals minus q. We have to then complete the square on the right hand side by adding half of the square of half the x coefficient to both sides. So add p over 2 all squared to both sides. This gives me x squared here plus px from this thing here plus half p all squared equals a half p all squared minus q. Remember, we have to do the same to the left as we do the right hand side. Now, this thing here is just a square of side x plus p upon 2 all squared. And that all still equals p upon 2 all squared minus q. And now we know how to solve this thing. We can take square roots of both sides. So I'm left with x plus p upon 2 equals plus or minus, remember, the square root of p upon 2 all squared minus q. And then the last step is just to move to subtract p upon 2 from both sides. So I end up with x equals minus p upon 2 plus minus the square root of p upon 2 all squared minus q. And this is not something you have to remember, it's in your formula sheet, but you have to be able to apply it. We're going to go through an example of this in class. Just to make things a bit more complicated, the English language system actually has a different formula, so there are two formulas. If we have a formula in the form x squared plus px plus q equals 0, then the solutions are x equals minus p upon 2 plus minus the square root of p upon 2 all squared minus q. But if we have, this is when we have an x squared term with no coefficients. If there's also a formula to solve if we have ax squared plus bx plus c equals 0. So we do have a coefficient in front of the x. And this solutions are found also through completing the square. Exactly the same. You get exactly the same solutions out, but you just have to. Here we have do not have a coefficient in front of the x. Here we do. Let's start by dividing everything by a. I get x squared plus b upon ax plus c upon a equals 0. Subtract c upon a from both sides. I get x squared plus b upon ax equals minus c upon a. I then have to complete the square. I have to add half of the x coefficient to both sides. I get x squared plus b upon ax plus b upon 2a all squared equals b upon 2a all squared minus ca. What I have here on the left hand side is a square of side x plus b upon 2a all squared. I get, if I multiply out the brackets, I get x squared, x times x, plus twice x times b divided by 2a, which is bx divided by a, plus b upon 2a all squared. So I get back to this, if I multiply the brackets here, I get back to this thing here. Equals b upon 2a all squared minus c upon a. Then if I take the square roots of both sides, I get x, I can take away the squared, x plus b upon 2a equals plus minus the square root of b upon 2a brackets all squared minus c upon a. And then finally x equals minus b upon 2a plus or minus the square root of b upon 2a all squared minus c upon a. Now, by doing a bit of algebra, you actually can get from this to the formula that's in the formula booklet, which is x equals minus b upon 2a plus or minus the square root of b squared minus 4ac all over 2a.